This is an interesting interaction between absolute value symbols and fractions. And what it's asking is which one of these expressions has the greatest value? Well, what we're given is that d and a are real numbers. That's not very helpful. But they have equal signs. That is helpful. And furthermore, d is a smaller magnitude than a. So let's deal with the different situations that we might have. First, suppose that a and d are both positive. And I know I can say that because they have equal signs. Now, maybe they're both negative. We'll deal with that in a moment. But suppose for a moment that they're both positive numbers. Okay, what do we have here? I want to remind you of something, which is that if you have a number and you divide it by something small, you get something big. And if you have a number and you divide it by something big, you get something small. So keep in mind that we're looking for big results, right? We want things with the greatest value. So how can I get great values, right? The big things, I have to divide them by small things. So do you see anything over here on the left that is clearly dividing by something small? Well, what we know is that d is smaller than a, right? So this one, maybe, because I'm dividing by something small. This one, maybe, but I can rule out the dividing by a's, because if you compare these two, let's compare these two right here. Compare this to this. You see that on the top it's the same. The only difference on the bottom is that one's divided by d, one's divided by a. So we're naturally going to pick the one that divides by the smaller number. That's not a. So I can rule out this one, and for the same reason I rule out the other one. So now I'm down to only 3 options. That's better than before. And if you think about the idea of dividing by something small again, remember d and a are both positive numbers. That means d plus a is bigger than d alone. For that reason, I'm going to cross out this other one right here. So all I have left is d minus a and d plus a. So if they're both positive numbers, which is bigger, the sum or the difference? Right? In other words, here, let's do some examples. 2 plus 5 equals 7. 2 minus 5 equals negative 3. Now remember, there's absolute value symbols. So what we get is 7 versus 3. It's obvious that the difference will always be smaller than the sum of two numbers. If you want a number line example, imagine you've got, 0, some number here, a, and some number here, d. Well, if you take the difference, that's only a small distance right here. But if you add them up, you're getting something much bigger. You're adding this line to that line. It's much bigger than the difference. So that's always going to be true. Okay, so for the case of positive numbers, the greatest value is always going to be this one. You have the biggest thing on top that you can have, and you have the smallest thing on bottom. Now, does anything change when it's negative? Well, think about that for a minute. That might be a useful exercise for you to go through. But it turns out nothing changes if it's negative. This argument is completely the same. And I'll use the number line example right here, except now I'm going in the negative direction. I've got some negative number d and some negative number a. Okay, and these are negatives. And still, if you look at this from a number line, the difference between them is still smaller than the total distance of the two of them added together. So that's true. And if you divide by a negative small number, you get something with a large magnitude. If you divide by a negative big number, you get something with a small magnitude. There's going to be negative signs to deal with, but guess what? These absolute values over here are going to whack any negatives that you're looking at. Okay, so those absolute values kind of make this negative versus positive question an unimportant question. Okay, what we're really looking for is, here's the key word, the greatest value.